Thank you, everybody, for coming. So I will be your first lightning talk speaker. My name is Paul Andrew. I'm a principal consultant from the UK, which is why I sound funny, but I am talking properly. You're all wrong. No, just kidding. So I am going to talk to you today in my 10 minutes about DevOps and Data Factory. Is anyone here using Data Factory? Did anyone use version 1 of Data Factory? OK, that's fine. We don't need to cry about that then. Good. So if you want a copy of my slides, you have 7 seconds to take a picture of this one. There is a PDF of my slides in my GitHub repo. But as none of you got your cameras out, I assume you're all here to see the other speakers, which is good. Data Factory, a very quick overview then for anybody that hasn't used it. What is Data Factory? If we have some process where we want to get our data from A to B to C, whatever, you know, the usual story, Data Factory sits there as the orchestrator of that. It is the umbrella service that sits above the process, looks after it. It tells these services what to do effectively. It will go and invoke the parts of this process. So it's quite bossy in that sense. And if we're extending that analogy, we could say that my wife is Data Factory. She is the bossy one. I am the process doing all the work. She tells me what to do. I go and do it. So that is Data Factory, the orchestrator of this process. If we go a little deeper and we actually look at the components we need to build within our Data Factory to orchestrate something, we have 5 of them. Firstly, link services. Are we fans of SSIS in here? A little bit, yeah? So our link services within our Data Factory, very much like our SSIS connection manager, they are the thing that we need to use to authenticate against our other services in Azure. Connection details, host names, the usual bits and pieces. Next up, number 2, are data sets. We need to define the metadata that we're going to use, the thing that we're going to work with. Maybe in the case of a SQL DB, the data set would tell us the table, the schema, the structure of it, the data types that sit within there. And those data sets will authenticate against our link services, number 1. Number 3 is this thing called activities. So when Data Factory is being bossy and telling a process to go and execute, the activity is the thing tailored to the service that it's going to go and communicate with. So if we're invoking a Databricks notebook, we will have an activity that says, use this workspace, use this notebook, pass these parameters to it, and that information is in the activity. And just like our data sets, our activities will authenticate with our link services, number 1. Number 4 are pipelines. Now, we could say this whole process is our data pipeline, you know, this pipeline of things that is running. Fine in that context, but also a pipeline is a component of our Data Factory, and it allows us to group our activities together. We could have a pipeline containing all of our ingestion activities, one containing all of our transformation activities, whatever, we don't mind, it's however you want to wrap them up. We can also call pipelines with other pipelines. We can chain them very much like our SSIS packages. Then, lastly, number 5, are triggers. Our triggers will attach to a pipeline or many pipelines, and those triggers will say, yes, go and run maybe recursively on a schedule, trigger them from logic apps, trigger them when a file is created in our blob storage account, whatever we want. So those are our 5 components of Data Factory, and as I say, Data Factory is an orchestrator, and its hymn sheet is JSON. So all of those things, we create the JSON to allow Data Factory to orchestrate that process. So that's our quick intro. Now, obviously, the main thing I want to talk about is how we deploy that, how we deal with Data Factory, how we get it into production. So firstly, let's think about developing it. Data Factory, it does not have a local developer experience, a local developer tool. We have to use the portal. We have to have a browser. We cannot develop Data Factory on a train, sadly, because we all want to. If we have multiple developers, they can all connect to the Azure portal, they can interact with it, and then we can potentially, with our one Data Factory, allow our developers to add what they need, to run that pipeline, and they get a debug service that sits there, and they can execute the things they have created. They can also potentially publish that data factory. If we have one service, they can take what's in that debug environment, that dev environment, publish it, and then we have that data factory that could be our production environment. Now, that's not ideal, I appreciate, but that is one option, and that is how maybe our developers might work when they're all doing things in our data factory. But, you know, we are good developers. We don't necessarily want to do that, so let's just park that idea maybe of having a single data factory, and let's call that option 1. Option 1 of deploying our data factory if we only need one of them. But, as I say, we are good developers. We want, of course, multiple environments. If we want multiple environments for our data factory, we will need to use something else. We will need to take that JSON from the development environment, and we will need to, via Powershell, via the ARM templates, whatever, take that through and deploy that to some other services. So let's class that then as option 2. And let's go deeper into option 2, because there are some now nuances, there are some quirks of that that we need to understand. The first one is that if we have that developer doing his work, and if the developer is working in the debug environment, fine. When that developer hits publish, and maybe hits publish to the dev environment, fine, he can do that. What actually happens behind the scenes, if you look at your Git repo or whatever, it has a separate branch that Data Factory will create that you have no control over, this ADF_publish branch. And what you'll find when you look at that branch is there'll be a series of JSON files that represent the ARM template that is then going to be used when that Data Factory passes over to its published service. So that's okay, maybe we can deal with that, we can work with that. So let's now break out our DevOps tool, our Azure DevOps tool. Do we like this tool? Who likes it? Who doesn't like it? Indifferent in this room, good. So in our Azure DevOps tool, if we want to do this, if we want to use this process, we build our artifacts, we build our data factory, and we get that ARM templates, that thing that we can then use. And then we have a series of release processes, which for some reason the icon for that is a rocket, which is excellent. Launch the data factory. And within there, we have a pipeline again. Let's overuse this word, but this is now a release pipeline. And that release pipeline can have a task. That task could be to deploy this Azure resource, this ARM template, if you like. So that's fine. We take our ARM template that we've got from our dev data factory. We override the parameters on it. Maybe we have some scoped variables, some group variables within our DevOps environment. And we do that, and maybe we get our test data factory, if we like, sure. We clone our release pipeline, we go again, and we get production. This works, we can do this. Now, this, of course, requires some manual operations, some manual interventions, so let's think about how we trigger it. Now, typically, what I might do is, depending on my branching within my source repo, I will say when a feature branch is merged into master, I will trigger the build, and then maybe when I create a release branch with a particular name, I might trigger the rocket to go and launch and to actually publish Data Factory to that environment. Now, branching strategy is probably a separate topic on its own. So what I'd say to you is that I'm a fan of Git flow. If you want to grab that PDF out of my GitHub repo, I've hyperlinked that logo. Have a look at the Git flow branching strategy. It's quite good. I have a customer that is a retail customer. They have 4 separate brands. We have a single code base. They have 4 environments for every brand. So I have 16 environments that I have to look after. And Git flow does help me with that. So check that out. Now, the other thing we need in here, because we are good developers, is gateways. We want to approve when that data factory goes into production. And I do not trust my developers. I want it to alert me before they go into production, so we can build that into our DevOps process as well. Now, this is all good. This is one way to do it. This deals with our option 2 if we like. But the 5 components that I talked about in our data factory, when we do this, all of those 5 components are wrapped up within the ARM template. We have no control over it. They're all there. And Data Factory, it's a highly dynamic service. We can do lots of things in here to make it metadata-driven and to inject into that JSON. But sadly, with that ARM template, the only thing we get to parameterize is the linked services, those methods of authenticating against those other Azure things that we want to go and invoke. So, that's OK, but I want more control. I want to be able to parameterize more things at deployment time. So what can we do? Well, we can scratch that ARM template, and what we'll actually find is that if we look at our source code repo, we will find all of the JSON files for each component of our data factory in there, alongside that ARM template in that ADF publish branch. So what we could do is instead is use those for the deployment. And in that case, we might scratch those ARM template tasks. And what we could do is use the PowerShell commandlets to deploy our data factory instead. Sure. So we take those JSON files, we give it to the appropriate PowerShell commandlet. We also give it some parameters to override those things that we want to give us that control. And that works. And I'm going to call that bonus option 3. But there are caveats. So having tidied up that slide and considering that maybe we use, is that 10 minutes? Is it 10 minutes? Brilliant, nearly done. So given that then, if we're using those JSON files, we override it. There are 2 big caveats, and that is we can't handle dependencies. Within our ARM template, it knows that a data set has to authenticate with a linked service. OK, I get the hint. It knows that a data set has to authenticate against the linked service. It understands that the linked service has to be deployed before the data set. If we're doing it with PowerShell in bonus option 3, we just need to deal with that ourselves. It won't also deal with removals. If we rename a data factory pipeline, it's just going to go and add the newly named thing. It's not going to take away the one that's there. So we will have to handle that as well. OK? That is bonus option 3. And very quickly, to summarize, if you want to do Data Factory DevOps, if you want to deploy it, here is a summary of the questions that you need to ask yourself. What branching strategy, what Git repo are we going to use, whether it's the hub version or not? How many data factories do we want? What deployment method are we going to use? And what artifacts are we actually going to use to do that deployment? Thank you very much for listening, folks. As I've said, those slides are in a PDF in my GitHub repo, Mr. Paul Andrew, the same as my Twitter, the same as my blog, the same as everything else. Thank you very much.
All right. So hi, everyone. My name's Mike Grayson. I'm from Paychex, and I'm going to talk a little bit about SQL Server and MongoDB, a side-by-side how-to. So my talk is for the DBAs or engineers in the room who have their developers or someone else come to them and say, oh, yeah, by the way, we've been running this application on MongoDB, and guess what? You get to support it now. And we're like, OK. What does that mean for us? So a little bit about me. I work at Paychex in Rochester, New York, as a database engineer. Yeah. I've worked with all kinds of databases. You'll notice the one that's missing is the one that pretty much everyone's here for. I'm a MongoDB master. I've previously been in support and a developer, and I'm married with 4 kids. So what I'm going to talk about, I'm going to give you a brief intro to MongoDB, just kind of level set so everyone kind of knows what it is. Some high-level overviews of when you should use Mongo and when you should use SQL Server. Some terminology differences, comparing them all, where I'll kind of run through a lot of the queries and stuff that we're used to in SQL and how you would run that in Mongo. So what is MongoDB? It's a NoSQL database, which doesn't mean that you don't use SQL. It means not only SQL. It's a document store database, which if you think about a document, I'll kind of demonstrate what that looks like in another slide. It's just a different way, a more human readable way to kind of represent our data. It's highly available through built-in replication, and it has horizontal scalability through the concept of sharding. So on the left is what a table looks like, what we're all familiar with. On the right is a document. The right is kind of how MongoDB represents their data. This gets powerful in the sense that you can have arrays of data. For example, if you think about in a relational database, if we had multiple phone numbers, that means multiple columns. In Mongo, I can have one record that has, say, cellular, home, and pager for those that still have that. And then the next record can just have mobile. They don't have to match. Everyone always says it's schema-less, but it's not really schema-less. The schema is kind of a little bit less strict than we're all used to, which has its pluses and minuses. So when should you use those? The relational databases, whether it's be SQL or the others, if you have complicated querying, which what I mean by that is joins and things of that, transactions, routine analysis of data, continue to use your SQL Server. If you need referential integrity or ACID compliance, again, continue to use SQL. And just anything where you have highly relational data. When should you consider using a NoSQL database such as Mongo? If you're storing serialized arrays that are already coming in as JSON. If you're storing records in the same collection that have different fields or attributes. If you have a constantly changing schema, this can be a very good use case for a MongoDB. If you have semi-structured or unstructured data is another one. And again, with the lines blurring, with all the new SQL Server releases and all the new Mongo releases, some of these even you can make cases for either way. Some quick terminology differences before I kind of get into how you do some of the things in Mongo. A table in relational world is a collection, a row is a document, and then a column is a field. So if I'm referencing a collection, just in your mind say, OK, he means table. So the first thing I'm going to walk you through is how you create a database. And just like SQL Server, there's probably a million ways to do each of these things. So if the way I do it isn't the best way, don't get hung up on that. So in SQL, it's just create database dogs. Mongo's a little bit different here. Mongo will implicitly create both your database and your table when you insert the first record to it. I can still go and create it ahead of time, just like I could in SQL. But it's kind of cool that you can, with your first record, you get your database and your collection. So like in that example, use dogs tells it it's going to be a dogs database. And then the db.breeds says, create the breeds collection when I insert this record. So object creation, how would you create a table or a collection? We know how to do that in SQL. In Mongo, again, like I just mentioned, I could just insert the first record and this will get created. Or I could just do db.createCollection, Dataset. I used an example. Kim and I did this talk at a couple SQL Saturdays. We both found out when we were preparing the talk that we both had Basset hounds, so you'll see lots of references to Bassets. How do you add a column? In Mongo, again, this is a little bit different. And just for those not aware, if you haven't seen JavaScript before, a lot of the Mongo query language is very JavaScript-esque. But anyway, in Mongo, to add a column, you actually just update the records. That's where you see that $set. And that multi-true means I could update it in just one. Since all my records don't have to match, I can update it in just one, or I can update it in the whole collection. Create an index. This is pretty much exactly the same as indexes in a relational world. We have your text indexes, your multi-key indexes, all of that. And that's just the create index command in Mongo. Removing a column, again, in Mongo, I can do this for one record, or I can do it for the whole collection. Those two brackets right after the update, that's basically an empty set. So that's just saying select star from, essentially. Or in my case, it's select without a where clause. Creating a role. MongoDB is more like Oracle and MySQL when it comes to roles and users, in that the roles can be scoped to different databases, or they can be scoped to specific privileges. You have create a role. You can give it privileges and actions. Again, you can give it at the database level or at the collection level. So it's got the same fine-grained security role-based access as we're used to. Creating a user. This, again, is more typical to some of the other relational databases out there where you can create it. The admin database in MongoDB is pretty similar to the master database in SQL Server. So if I create something in the admin database, that could have privileges that span multiple databases. Or I can scope that, again, I can create the user that really only exists in one database. And then assigning the role is kind of the same concept. Some CRUD commands. Inserting a row. So in Mongo, again, I don't have to have the database and the collection exist before I insert a row. Otherwise, it's the same basic concept of when I'm inserting. I don't have to even know all the fields, technically. Finding a record. This is just db.collectionname.find. Updating a row. Some of the previous ones with my updates, I had update, and then you saw I had multi equals true. I can also just tell it, update everything that you find with the update many statement. So that's kind of goes back to what I started with there's many ways to do things, even in Mongo. And this is just setting the PK, or resetting the PK. And of course, you got to delete. There's delete, and there's delete many. Again, same concept. Where if you only want to delete the first record you find, you'd use delete. If you want to delete every record that you find that matches your where clause, that's where you'd use delete many. HRDR options. We're all kind of aware of what's available in SQL Server with failover clustering, availability groups, always on all that. In Mongo, there's kind of two main options. From a clustering perspective, there's sharding, which at a high level, if you just think of this as partitioning at a server level, that's kind of what MongoDB sharding is. And then for disaster recovery, they have a concept of replica sets. This can be 3 or more members. They all replicate the data. With automatic failover, it has an election process. Has a concept of an arbiter, which is like a witness server in SQL Server, where its only purpose is to vote in those elections. So that helps you kind of ensure that your failover happens to the server that you want it to. And the other important part, and this is kind of why we're here, and this is also important with other databases as we learn them, is to connect with the community. If you're new to a database technology and you don't know where to start, there are communities out there, whether it be for Mongo or Oracle or MySQL or Postgres. So I just kind of want to emphasize the importance of that. There's MongoDB. Being a newer database, they still sponsor a lot of their own user groups. They have 2 main conferences. They have their own, and then the Percona Database Conference, which is just for all open source databases, which MongoDB is one. And I listed out the local group for the Seattle MongoDB user group. And with that, I am done. Presentation number 1. And don't worry, I won't just be reading the slides. Kim and I did a longer version of this talk in, I believe it was Cleveland, earlier this year. So I actually know what I'm talking about. So I am not Kim StJacques. I do work at Paychex, though, so that's still true. I haven't been in the industry for 20 years. She has. And if you play Overwatch, that's her Overwatch tag. She likes to play and talk to people about cool stuff. So we're going to talk about PolyBase, kind of give an overview of what it is, some of the benefits of PolyBase, and then how you use PolyBase. we're going to also dive into we're going to focus more on the enhanced PolyBase feature that was released in 2019 and talk just a little bit about the PolyBase in 2016 as well. So first off, what is PolyBase? If you're not familiar, it combines disparate data sources for reporting inside SQL Server, and you don't need ETL processes. You also get to use T-SQL, which probably everyone else in the room besides me is quite familiar with. And it uses external tables to create data located on an array of data sources. With the original version of PolyBase, the external data sources were HDFS compatible, whether it be Hortonworks and Cloudera, which are now one, or Azure Blob Storage, or the other HDFS compliant Hadoop offerings. So in 2016, when it was introduced, again, like I mentioned, it only supported HDFS, HDFS compliant Hadoop distributions and Azure Blob Storage.
How many people use Hadoop? Yeah, not very many. So this was like, it's a great feature, but it wasn't very useful to a lot of people.
Right. So in 2019, they came up with Enhanced PolyBase. So this combines many more disparate data sources, still using T-SQL with this wide array of new data sources. And now not only does it support Hadoop, which again, we saw a few hands, and Azure Blob Storage, now it supports SQL Server itself, whether it be Windows or Linux, Oracle, MySQL, Mongo, basically any data source with an ODBC driver. So let's see a show of hands now where any of those data sources matter. Yeah, a few more hands. So what is Enhanced PolyBase? Again, lots, as Bob Ward likes to say, lots of icons up there on what it supports. Anything ODBC down to Excel. NoSQL, whether it's Mongo, Cosmos, Cassandra. All your other typical relational databases. And then still your big data like Cloudera and Hortonworks, but now also Apache Spark, which has kind of taken over Hadoop, the Hadoop space. So what does the PolyBase architecture look like? You have a PolyBase group, which kind of holds several different portions. There's the head node. This is kind of where you're, and I'll get a little bit more into the head node. Head node will have a SQL Server instance, the PolyBase engine service, and the PolyBase DMS service, which is data movement service. You also have what are called compute nodes or compute instances, also SQL Server, and also with the DMS service. And they can reach out to the compute nodes can reach out to these multiple database types, or sorry, data store types. So let's get a little bit more into the head node. This is the instance where you submit your queries to, just like you would any other SQL Server. You can only have one, and it must be Enterprise Edition. So the head node parses the submitted queries and then distributes the query plan and work to all those compute nodes. So you can kind of see where this is going, where the kind of the power of being able to use those compute nodes comes into play. And it also returns the query set results back to the client after it gets it from the compute nodes. The compute nodes, they assist with the scaling and out of the query processing on external data. They can be enterprise or standard edition, which can be nice from a licensing perspective, especially if you want to have multiple ones. And they do send the results back to the head node. Some of the benefits of PolyBase. First one is data virtualization. And Kim found this great quote from TechNet. The data virtualization can be defined as a set of tools, techniques, and methods that you let access and interact with data without worrying about its physical location and what compute is done on it. So if you think of traditional ETL processes, something like this is very powerful. So you'd save on storage because you're not truly replicating the data from your disparate data sources into SQL Server. And we'll kind of show that with some of our quick examples. You have near real-time data at your fingertips. It's more secure, again, because you're not having the data replicated. There's still considerations, obviously, on the SQL Server side to limiting the access to data. You can bring structured and non-structured data together. That guy that talked about non-structured data in that last talk, you don't need him anymore. So, and the consumers of the data only need to know T-SQL. So if your BI teams, your analytics teams, are used to querying against your SQL database, they can do this now. You can have your developers bringing in Mongo. You can still have your developer, or your BI or your analytics team query against it with T-SQL. So how do you use PolyBase? How do you configure it? What you need at a minimum is a database on your head node, credentials to your disparate data sources, data source definitions, and external tables. So to create a database on the head node, you'll need the credentials for your disparate data source. You'll need your data source definitions and the external tables. You create the database just like you would any other database. There's nothing special about that part. You do create a master encryption key. And this is to encrypt all the credentials and all the things flowing between your SQL Server and your disparate data source. So to create a credential, you'll use your database. And then you basically, at that point, you create a scoped credential. In this case, it's to an Oracle database where the Oracle user is Poly and the secret is Cracker, aka the password. So then once you've created those credentials, now you create the external data source. So this has your location. So this is basically your connection string to Oracle. And again, in this example, there's a concept of push down. Push down, off, or on basically is where do you want this query to run. You can push it down to the disparate data source. So if you're querying, for example, if you're querying Mongo data, it's probably better to push that down to Mongo because Mongo is going to handle it better than if you brought it into your SQL Server, potentially. Or with Oracle, maybe you have a crap ton of data in Oracle and you don't want to bring that into your SQL Server. So that's two of the times where push down could be very effective for you. And then you reference your credential, your scoped credential, which you just set. So now we're ready to create an external table. So this is really where you're telling SQL Server what your data should look like when it's in SQL Server and where to get it from. You have your columns, your data types, the location. So with Oracle, the location is basically your instance ID, your schema, and then the table name in Oracle. With most other databases, you only have two here because Oracle's kind of unique with its instance ID, the way it uses it. And again, you reference your data source, which you just created. Once you've created those external tables, then you create statistics on it. And this is so that SQL Server can query it in a more quick manner. One of the things Kim and I found when we were doing this, you probably noticed on this previous column, we had a bunch of different data types. Using Oracle as an example, it's not always easy to say this data type in Oracle must be this in SQL Server. Gets even more crazy when you think of the MongoDBs or the Cassandras or the HDFS or Spark file systems. So one of the things we found that was kind of cool was SQL Server will tell you what kind of data type it's expecting. So if you try to create it with, using probably a poor example, if you try to create a Boolean on a table that should be a float, it'll tell you. It's going to say, yeah, you thought it was this, but it's really this. And that was kind of helpful. In 2016, all you got was an error message. It didn't tell you kind of why it was erroring. So what does this look like in SSMS? Pretty much like any other table, other than it being under the external tables section. And what does it look like when you query PolyBase? It looks like just you're querying any other table. So your BI, your analytics folks wouldn't even know they're querying, for example, Oracle or Mongo. You just do your select star from table, or obviously you can do more complex queries just like you can in regular SQL Server. What you kind of don't see behind this query is each of these tables is actually a reference to another database. So I think in this one, it was Cosmos DB, MariaDB, MongoDB, a SQL Server on Linux, each had their own table, and we were able to join them all, basically 6 different databases on 6 separate systems, all in one query, and get that data surprisingly fast, given, given that. Yes, and external tables can be queried just like a normal table. You get the results back exactly like it was a normal table. And with that, Kim and I are done.
So about a month ago, somebody had to drop out, and they asked me, hey, do you want to do a lightning talk? And I said, yeah, that'd be great. I'm really excited to present at Past Summit. Normally, I don't get the opportunity for various reasons. And I thought, what could be the most exciting talk to give in 10 minutes? And I thought, I know, Power BI licensing. So we're going to talk about Power BI licensing. But first, we're going to use an analogy so we can kind of work our way through it. So who here rides the bus to work? Anyone? Like 2 or 3 people. If I worked in the city, I would totally ride the bus. Currently, my commute is 5 minutes at most if it takes me a long time to get coffee at home. But I want you to think about riding the bus. We had the chance to do that coming in here, potentially, because I found out the light rail does not work at 1 in the morning. So we ended up taking an Uber because we were just frustrated trying to figure out where to go to get the bus. But I have a question, and this is going to sound like a dumb question. Oh, no. Gone forever. All right. I'm not going to use that anymore. I've got a question for everyone. Which is cheaper? If we needed to get from SeaTac to here, would it be cheaper to buy a bus, or would it be cheaper to buy a bus ticket? Now, hopefully everyone here thinks I'm an idiot and is saying, well, it's cheaper to buy a ticket, right? A ticket's like $2, $3. A bus is like $20,000, $40,000. I don't know. How expensive could it be? Well, the answer is it depends, right? And the key thing it depends on is, well, how many people do you need to haul around, right? Because imagine you're Microsoft, and you've got all these employees that need to get to the Redmond campus, and you want to do them a favor, and you want to go green, and so you want them all to take this sort of public transportation. But you realize after a while that, wow, if I've got 100 people, it'd be a lot cheaper to just buy a dang bus and shuttle them back and forth, instead of buying a bus ticket every single time that we want to shuttle them around. And so that brings us to everyone's favorite topic, which is licensing. So when you're dealing with Power BI, there's 2 types of licensing. There's user-based licensing, and there's capacity-based licensing. And the key thing I want you to get away with this talk is that user-based licensing is like buying a bus ticket. You're licensing that user, that individual. Capacity-based licensing is like buying a whole darn bus. And so you're usually going to be paying $10 per user per month to buy the bus ticket, which is Power BI Pro. That's kind of the default way that people are going to use Power BI and PowerBI.com on a day-to-day basis. But again, you may be a huge enterprise, some Fortune 500 company, and you've got hundreds of people using Power BI. It is the bee's knees, and everyone is just utterly excited. And so you may decide, OK, we're going to switch to capacity-based licensing. We're going to buy a bus. And so capacity-based licensing trips everyone up because it's a little bit weird. One, you're no longer licensing individual users. Okay? What you're doing is you're buying capacity. And when I say capacity, what I mean in most cases, we'll get to report server in a minute, but normally when people talk about Power BI Premium and capacity-based licensing, it's a VM somewhere in Azure, right? Microsoft isn't going to call it that, but it's basically you're paying an extra fee to run Power BI, the Power BI service, on a VM somewhere. That's what's going on, right? And one of the important things to think about here is just like with buying a bus, if nobody gets on the bus, you still have to pay that payment plan, whatever that is. You know, you still have to pay your $500 a month, or if we're talking premium, $5,000 per month, right? And if you decide, you know what, we're going to ignore any fire safety codes and we're going to shove 200 people onto the bus, it might smell a little bit, but you can still do it, right? Same thing with premium. Like, you can have thousands of users on that little dinky VM that you're buying off of Azure, but you may not get the best performance, right? So when does it make sense to do which? The short kind of rule of thumb that I want you to get out of this is that whenever you're starting to talk 250 to 500 users, depending on what amount of functionality you need, the 250 is just you want to be able to embed in, say, SharePoint or something like that, and the 500 is you want to be able to actually use the full PowerBI.com experience. That's the break-even point. And the math is super simple. We'll get to the math a little bit more in a minute, but the math is really simple because basically, if it's $10 per user per month, you just divide the cost by 10, and that's how you figure out this break-even point, okay? So once you're talking 250 to 500 users, that's when you should start thinking about premium capacity. Now, Power BI Report Server, we'll talk about that in a second. That's a different case. That's more if you need to be on-prem, but that's your break-even, okay? So we've got 3 types of user-based licenses. Okay, but it's going to be really easy to keep track of this. So the first one is free. This is trash. You don't want to use this. Just telling you right now. And there's a couple reasons. So the first one is you can't share anything with a free license. That's the first issue, right? The only way that you are permitted to share content with a free license is publish to web. Publish to web means publicizing your data, making it public, which means that if your data is regulated, you just got fired and audited, right? So you can't really share in any secure kind of way. And they're really weird about what accounts you can use. So you can't sign up with a Gmail account. You can't sign up with a Hotmail account. You can't do any of that kind of stuff. It has to be a business account, or at least you have to have your own domain. So it's just this weird land between a personal account and a free work account. It's just, don't use it. If you want to like have some charts and graphs for your daughter's lemonade sales, this is perfect. Otherwise, what you want is you want Power BI Pro. This is going to provide you the vast majority of features. This is their one-size-fits-all kind of licensing until they decided they needed more sizes, right? There's very rarely going to be a case where this isn't going to meet your needs. And then the other user-based license is Office 365 E5. And so they've got these 3 levels, E1, E3, E5. There used to be ones in between, but then they went away. And this is basically the Cadillac version of Office 365. But if you don't need those extra features, you're still cheaper just having a regular mid-tier Office 365 and then Power BI on top. Because I think it's like $35 a month for the E5. Don't really need to worry too much about that. So capacity-based licenses. So there's 2 to 4 different flavors depending on how you count, okay? So the first capacity base is Power BI Report Server. Hopefully no one from Microsoft is here, but I'm just going to tell you, it's just SSRS. Like literally, for a demo when I was poking around, there was an Angular JS flag that said like Power BI branding, and if you changed it to false, it turned back into SSRS. It's the same code, right? They just added, I kid you not. I was like, man, I need to do demos for my courses on Power BI Report Server and SSRS, and I'm poking around like, oh, I can just change the branding. It's basically the same, it's just licensed differently. So you either need, there's 2 ways to license it. You either need Enterprise Edition plus software assurance, so core-based licensing, that's a lot of money, or you need Power BI Premium, the P level, which we'll talk about, which is also a lot of money, and then you get that included. So capacity-based licensing, the first option is Power BI Report Server. It's SSRS, just a different licensing model. The other option is Power BI Premium. And so this is a good example of one of my frustrations with Power BI, because I swear to goodness, 5 years ago, Sadia sat down with marketing and said, all right, we need to make more money. How can we make more money? All right, well, we need something that's going to kill Tableau, because they're making really great pie charts. It needs to be cloud, because that's where we make our money, and it needs to be software as a service. And I hear that agile is the thing to do, so let's do it agile. And what you get is you get all these different deployment and licensing methods, because every 6 months they seem to add a new one. But basically, you can buy some rinky-dink VM in Azure somewhere, and there's 3 different levels. A is for software vendors. This is basically you're writing software and you want to embed Power BI reporting into it. EM is I don't need PowerBI.com. I want to embed in Office 365. So I want to embed in Teams. I want to embed in SharePoint, that sort of thing. And then P stands for premium. It stands for platinum. It stands for pretty freaking expensive. You get the entire PowerBI.com experience with the P level. So what do I mean when I say pretty freaking expensive? Well, here's the 3 different tiers. And so for the P tier, you're starting at $5,000 per month, right? Because you're basically buying a whole VM in the background that's running all of the time. That's an expensive bus. So unless you know you're going to have 500 people you're going to throw on that bus, you really want to think that through. Finally, one last gotcha. You still have to license the bus driver. This is the dumbest thing. You could be paying Microsoft $5,000 per month, and you still have to pay for a pro license for every report creator. So anyone who's creating content still has to have a Power BI Pro license. So you're going to be paying $5,010 per month minimum. So that's a quick gotcha. Finally, the takeaways I just wanted to give you all is Power BI Pro is cheap. It provides most of the features you're going to need. And really, the only reason to ever look at capacity licensing in most cases is either you need to be on-prem or you need to deal with 250 to 500 users. Okay? Thank you very much. Here's my contact information.
So we're going to talk about data privacy today. Hang on, I just want to get my timer out. Make sure I don't overrun. Right, so today we're going to talk about data privacy. So last presenter left you with, well, started with a couple of questions. So I'll start with a couple of questions as well about how's your business. Do you think every business nowadays is an IT business? It's hard to think of a business that doesn't run on IT. But there's the local plumber who comes to your house, might have names and addresses in his pocket. Maybe not all businesses are IT businesses. But is every business a data-driven business? It's hard to think of any business that doesn't rely on data of some kind. So is every business basically an IT and data business? Well, potentially, yes. But more than that, every business is a people business. So whatever business you're in, at the end of the supply chain, there's people doing something. You do a job to create wealth or whatever for people at the end of the day. And that's starting to bring with it a massive headache. So we've got to look after all of that data. And just looking after that data brings its own problems with it as well. So what does all that mean? Is every business a data privacy business? Well, potentially it is a data and privacy business. And where does privacy stop? And where does security begin? So we're starting to see lots and lots of legislation around the world aimed at the privacy and security field. And a lot has never really existed in the past. And if it doesn't exist, what's the minimum we should be doing? Should we be neglecting the data of our users, putting our production data into non-production environments because we know we can get away with it? I worked for an organization who said they did a census in New Zealand, and they said, right, we're not going to put any of our production data in development at all, because he had a bit of trouble with that previously. This is probably about 15 years ago. Nothing bad had happened to him, but the users inside the business had said, hang on, you shouldn't be transferring production data into development. But all of a sudden, they hit a bug in production, not a big one, and they decided, oh, sod what we've said, it's a good idea, we'll move our production data right into development, okay? Totally overrode everything they'd previously committed to. Their process went out the window, and the culture in that organization was like, let's just get the job done at all costs. Now, nothing untoward's happened there, but that's a good example of how the culture in an organization can override the good processes that have been put in place. And that happens quite a lot. And organizations as well are now starting to make you do training and that, so that when you potentially slip up, they can say to you, well, we told you you should have done that, and you signed something to say that you've actually read it and took responsibility for it. And one of those things actually took me 3 days to get through. I was amazed. But what's the cost of this? Because everything has a cost. So there's a time cost, a time in looking after passwords to get into places, a time for getting set up, and that's all got money. And that's got to be passed on to your clients. And it's getting easier and easier for clients to change who they bank with or who they shop with or whatever they do. And if you start losing business and your company starts losing money, potentially you're going to start looking for another job. But is there another side to it? We talked about remembering passwords and things a minute ago, and that's a huge headache for people. That you go to get into one of your clients, you're searching for password A that's maybe a big cryptic password that you don't know. What do? Do you go to an Excel spreadsheet where you've stored all your passwords? Maybe you do. I've seen some people doing that. Or maybe you do something like you've introduced an enterprise password safe where you keep all of your passwords for all of your secure things. Okay, so there's a lot of these about. And passwords are like toothbrushes, as we know. We shouldn't share them, but people do. So how can we handle them better? Well, one thing is I've learned in my career that enterprise password safes are potentially a good idea. However, you've got to make a decision yourselves whether they are suitable for you, because you've got one password to rule them all, so to speak, and what happens if that's compromised? Okay, so then you can put maybe two-factor authentication, multi-factor authentication on that itself, but on the passwords that are within the safe as well. Like we heard this morning in the keynote, there's no pretty bulletproof way to do this, and there's a massive trade-off in how you choose to handle your passwords. So I'm not advising you to go out using these password safes, and there's a lot of them about, but I would like you to consider maybe using one and the benefits that they can bring to your career. And not just your career, your own personal well-being. I use 1Password, and that integrates with my phone, and it also integrates with my browser, and has also got a thick client. I've done a bit of research, and I found that really useful. Using standards is a good thing. Windows authentication, Azure Active Directory. Maybe we can do away with that passwords. Maybe that's just a dream. Standard encryption, cybersecurity standards. A lot of people think that by using standards, it makes them vulnerable. In fact, probably the opposite's true. Like we said, I heard this morning, using strong crypto algorithms that are at the moment unbreakable and not deprecated is a good thing. Don't invent your own. I see people inventing their own quite a lot, and it doesn't work out that well. Let's talk about production data, putting it in non-production environments. Well, this has to be done at times. Ideally, you just generate your own set of data and have no recollection to production at all. But is that a good thing? Could you do it? But to get around that, we've maybe got data masking, static data masking, changing the names in your database to other names that can't be reversed, like just picking the name Martin, substituting it with Fred one day or George or whatever, the sort of thing that can't be reversed. Exchanging data in one list for data in another list. And you could do the same thing potentially with security, social security numbers, phone numbers, and all that sort of thing. Obviously, there's dynamic data masking as well, which came into SQL in 2016, and is potentially another alternative you've got in your toolbox. So, briefly to summarize some of the things we've talked about here, consider a password manager. Now, yep, go over the trade-offs. It took me a long time to come around to the fact that I potentially should be using one. I still struggle with what would happen if that was breached in any way. This is a big one we haven't really mentioned. Adjust your mindset to how the likes of monitor and auditing are used. A lot of people see these as tools to potentially catch you out or beat you up or discipline you or do something like that. But in fact, we can use them as tools to make our applications and our databases better. The sooner we know ourselves that something's wrong, the sooner we can fix it, and the sooner we can make it potentially more secure. So auditing, monitoring, logging, and all that sort of thing, if you can put it in your applications, your databases, good on you, it'll go a long way to helping you out. Implementing good processes. Like in my example, my organization had a process not to put data from production into development, but when the going got tough, their culture overrode it. And it's quite a big example, if you want to go and look, about the British House of Parliament's MPs in there sharing passwords because they found it easier to share passwords than to go talk to their IT team. Share your knowledge. Like we heard this morning in the keynote, sharing knowledge is a good thing. I think the lady advised something going on GitHub and that. Talking to other people, like at this conference, sharing knowledge, how do other people handle it themselves? And hopefully that will take some stress out of your life and help you enjoy your work. So thank you.
This will be a very short lightning talk, in fact, but also the only one with a demo in it. So this is about the Power BI REST API. And according to Microsoft's documentation, the Power BI REST API is a service endpoint to embedding and administration stuff and user resources. And if you want to know more about this, I have an ABC session on that tomorrow, the last slot of the day. This will probably be a bigger audience than tomorrow, but anyhow. Now, you have the opportunity to dig in there. This will not be going in details. I know what the abstract said. On the way over, I'm from Denmark. On the flight over, I decided that I wanted to do something different with this 10 minutes. So that's what you're going to see in a second. So actually, the REST API is a collection of all of these groupings, admin, apps, dashboards, groups, data sets, and whatnot. And you can manage all of those aspects, adding groups, import PBIX files, stuff like that, programmatically through PowerShell, C#, or stuff like that. So it's really, really powerful, actually. Tomorrow, these highlighted groupings will be dealt with in detail, and the other ones not so much. So it's an ABC, so it's about the basics of getting going and learning how to actually use an API and stuff like that. So just before I left for the past summit, a coworker of mine said something funny about we should have a bot doing this. And so I thought, yeah, why not do that? So I produced Cortana on the way over here. It's a distant relative to Cortana, maybe? I don't know. But what I actually did was just start up a bot project. You see this? Yep. So this is actually just 2 projects in here. And this is a bot project that comes out of the box. They have an Echo bot, which is just an ASP.NET Core project that actually, once you fire it up, will echo whatever you type in, and you can go from there. So I added a little bit of state to that so the bot knows at which stage we're at. And then obviously we needed to connect to the PBI API. So that's the other project. So now I'm going to start this one up. And what you will see is just a web page. But that URL is actually something that I can use in a bot tester like this. They have a bot framework emulator in here. And the URL up here is actually in what you want to use in that. So this one, I can use the open bot, and it already recognizes that there is a URL going on. So I connect to that. And then my bot is running. So now I can interact with my bot and say, hi. And it replies to me. Oh, sorry. Hi. It wants to know my name. OK. It's Jens. And then it gives me a couple of options. So what do you want to do today? Do you want to do any of the following things? Yes, actually. I'd like to add a workspace. But let's see. So just so you know that this isn't any cheating, I'll let you show. I'll show you the workspaces I have in here. And none of them named anything pass, right? OK. So I select 0. I want to add a workspace. So it prompts me, please enter a name for the workspace. I said pass Summit 2019. Hit enter, adding workspace, pass Summit 2019, and there. It actually returns the GUID with which I can then address the workspace in the browser as well, go directly in. And we can also go back and see if it actually created the workspace. Sorry for the slow connection. There we go. And there you have the Pass Summit 2019 workspace. So let's just select that. And then we'll go back to the bot. So I could also, in this demo, add a dashboard. So let's just do that. And because I've programmed in the state, it actually knows the workspace that I'm working on currently. So it's adding that dashboard to that workspace. So it's prompting me for a name. And let's just call that test. So adding dashboard test comes back with the GUID for that as well. And when we go in here, we can refresh the page and see that, OK, so there's my test dashboard. So the final thing that I didn't manage to get working within the C# application was actually importing the Power BI file. But I have a little backup for that. So once I know the group ID in here, I can copy that. And then I can go to PowerShell. First, I need to log in. I have a script for that. And then I have a little promo for Games Night tonight. I've downloaded some of the, there's a web page called Game Board Geek, which has a rating of all the board games out there. So I did a little PBIX file on that. So I just want to add in the group ID that I just took off of the web page, and then hit F5. It's going to return a GUID down here. This one, and that's actually for the report. So let's go back. Oh, so your data set is ready. It says, so we already uploaded a data set, Game Board Geek, and a report, Gameboard Geek. And we have a little report on the best rated game board to go by tonight. So if you see Gloomhaven tonight, you might want to go for that, right?
It's $140, by the way.
Oh, okay. Yeah, they didn't show prices in here. Yeah. Maybe that's next step.
Yeah.
All right, so in this bot emulator, we can track all activity actually going back and forth through the bot and the code itself. And let's see. I don't think there was more. No, thank you. That's actually what I had to demonstrate on the Power BI REST API. And if you want to know in detail how to go about, there's a lot about credentials you need to know and stuff like that. So show up tomorrow at my session and we'll go through that. Right? Thank you.